So this is G481 homework booklet question 19. We've got a lift which itself is 500 kilograms and can carry up to 8 people with a total mass of 560 kilograms. And the lift supported by a steel cable of that cross-sectional area, 3.8 times 10 to the minus 4. With the lift at ground level, the cable's at its maximum length of 140 meters as shown. The mass per unit length of the cable is 3 kilograms per meter. Show the mass of the 140 meter long steel cable is 420. Absolutely crucial. I failed to highlight it. Show is the central word there. So the answer is of no interest whatsoever because you know what the answer is you're heading towards. So what got the mark here is for having written out the sum 140 times 3. It's always a good idea to explain to the examiner what you're doing anyway. It can help you pick up the compensatory marks if for whatever reason you don't get the right answer. But here, no sum, no mark, as simple as that. The mark was for the 140 times 3. Then part B, we've got the lift with 8 passengers is stationary on the ground floor level, and the initial upward acceleration of the lift and the cable is 1.8 meters per second squared. Show the maximum tension of the cable at point P is 1.7 times 10 to the 4. Again, we've got show. So my explanation, my description is absolutely crucial. Now, straight away, as soon as I start thinking about this question, I realise I'm going to have to be dealing with MA. I've got an acceleration. I'm going to be thinking about net force. Or the weight is also going to be relevant, mg. So I'm going to start off by doing a little side calculation of the total mass. And if we just go back to the question, the total mass we're dealing with would be the mass of the people, the mass of the lift itself, and then the mass of the cable. So we're given the information about the lift and the cable, and the people inside at the very top of the question, and then in part A we worked out, or we talked about the mass of the cable. So fairly straightforwardly, the total mass is adding up the masses of the cage, of the lift itself, of the people, and of the cable, and that's getting me 1480 kilograms. So if we go back to the diagram again, I've got an acceleration upwards, so I'm looking for the net force in the upward direction, and upwards I've got the tension in the cable. It's the tension in the cable, the pull at point P, if you like, that's actually causing that acceleration. So that tension in the cable is upwards in the right direction, but I've also got the weight of those objects going downwards. So the net force is going to be the tension in the upward direction take away the weight in the downward direction. So if I go back to my solution, I've got that the T minus W is equal to MA. I fell into the bad habit of just writing down mg because I've written down W there, but MA, so what I've got there is that F, the net force, is MA. So the tension, which is what I'm trying to find, take away, there's mg, 1480 times 9.81 is 1480 times 1.8. And then I can simply add this term to both sides to get the tension as those two things added together. I end up at 1.72 times 10 to the 4 newtons. You'll notice there I've left one more significant figure than was in the question. That helps the examiner see that I've really done what I need to do, and I've actually calculated the sum rather than just kind of written down the answer they've given and written something above it. So that's very much worth doing. On some occasions actually getting the answer does get you the mark, as long as you're showing that extra significant figure. So always be in that habit with a show question, give the extra significant figure as well as the full explanation. And then finally calculate the maximum stress. So stress, simply force over area. We're given the area right back at the beginning of the question. So F over A, the force I've just worked out, divided by the cross-sectional area, 4.5 times 10 to the 7. So that's G481 homework booklet question 19.